Hi everyone, this is the lesson previous to the one that we're doing today. So this had to do with long division, and as you can see, long division can be a long process, and what you're going to learn today, it's a little bit easier, but there is a condition so that we can use that type of division, and that is synthetic division. So synthetic division, the only condition is that the divisor must be linear and have a lead coefficient of 1. If this is not the case, like if you have a quadratic or coefficient is not 1, we cannot use synthetic division. Okay, so this is the setup for synthetic division. Just like yesterday, this is a dividend, this is the divisor. So what you do is you set the divisor equal to 0, which means x minus 2 equals 0, and then you solve. And when we solve that equation, we find that x is equal to 2, because all we have to do is add 2 to both sides of the equation. So then that 2 goes here. So notice these here, these are the coefficients. So I'm going to write this in a different color here. So these are the coefficients, okay, of the dividend. So what does that mean? Just look at the coefficients of each one of the powers. So for example, x to the third has a 3 in front of it. X to the second has a -1 implied. And x to the first has a -2 as a coefficient. And then the constant, which is a number here, is a -10. Okay? So then for synthetic division, this is where you start. I'm going to drop the first coefficient, which is 3. And so as you can see, this 2 here, when you solve for x, that 2 goes right there. Okay, so you drop the first coefficient of the highest power, and then you multiply. So multiply 2 times 3, that gives you a 6. And that 6 goes here. Then you combine -1 and 6. So -1 plus 6 is a +5. Then you multiply 2 times 5, which is 10. And -2 plus 10 is 8. And then multiply 2 times 8, which is 16. And then -10 plus 16 is a +6. So as you can see, we have a remainder for this one. Okay, so we have a remainder, which means that this binomial is not a factor of this polynomial. So then the answer is 3x squared plus 5x plus 8 plus a remainder of 6 over x minus 2. So the answer to this problem is that it is not a factor. Okay, so it's not a factor of x minus 2 is not a factor of this polynomial. And also notice that this term here is 1 degree less than the original. Okay, so the original is the cube, now we have the square. So this is the process for synthetic division. So I'm going to go to the next example. If I set this equal to 0, then that means x is -5. Then I have the highest power I have is the square. The coefficient of this x square is 1. Coefficient of x to the first is 13. Coefficient of the constant here is 40. So then I'm going to drop the 1 first. And then we multiply. -5 times 1, that's -5. 13 minus 5 is +8. -5 times 8, that's -40. And 40 minus 40, 0. So now we have a 0 remainder, which means this is a factor of this polynomial. Okay, so the answer is this is 1x, or just x, plus 8. And the answer to this one is, the statement is yes, it is a factor of the given polynomial, which means x plus 5 is a factor of x squared plus 13x plus 40. Okay, next example. So for this one here, if we set x minus 2 equal to 0, that means we add 2. So then x has to be equal to 2. Coefficient of x to the third is 1. Notice we have a missing term here, which is the x to the second. So we have 0 coefficient for x to the second, and -3 coefficient of x to the first. And then the constant is -2. Okay, so again, the process repeats. You drop the first coefficient. 2 times 1, 2. 0 plus 2, 2. 2 times 2, 4. -3 plus 4, 1. 2 times 1, 2, and negative 2 plus 2, 0, which means x minus 2 is a factor of this polynomial. So the answer is 1 degree less, which is x squared, plus the coefficient of x is 2, and the constant is 1. So the answer to this one is yes, because we ended up with a zero remainder. So this is the answer along with the statement that says that it's yes, and we showed the work here. Okay. All right, the next example. So for this one, the highest power we have is 2, right? I mean, the 3. So then the coefficient of x to the third is 2. Coefficient of x to the second is 6. Coefficient of x to the first is 1. And the constant is 3. Okay. If I set x plus 3 equal to 0, then x is negative 3. So then let's drop the first coefficient and multiply. Negative 3 times 2 is negative 6. 6 minus 6, 0. Negative 3 times 0, 0. 1 plus 0, 1. Negative 3 times 1, negative 3. 3 minus 3, 0. So again, this one is a factor of this polynomial. So x plus 3 is a factor of this polynomial because we have a zero remainder. So the answer for this one is 2x squared plus 0x. You don't have to write it down. It's just 1. Okay, and the answer is yes, it is a factor of that polynomial because there's no remainder. Okay, last example. So for the last example, notice that this is x plus 1/2 equals 0. We said this equal to 0. So when we solve, x is negative 1/2. So then the coefficient of, this is the highest power of x to the 36. X to the second is negative 5. And we don't have x to the first. We use a 0 as a placeholder. And then the constant is 9. Okay, now we drop the first coefficient and start multiplying. Negative 1/2 times 6, that's negative 3. Negative 5 minus 3, that's negative 8. Then the next one we use is, so then when you multiply negative 1/2 times negative 8, that's positive 4. 0 plus 4, positive 4. Negative 1/2 times 4, that's negative 2. And 9 minus 2 is 7. So we have a remainder, and the answer is 6x squared minus 8x plus 4 plus 7 over x plus 1/2. Since we have a remainder, the answer for this one is no. It is not a factor of the given polynomial. And that's all for this lesson. I'll see you in class. Bye-bye.